Okay, just to finish off the last couple of parts of esters. So the first thing you've got is uses. So first of all, esters are volatile liquids. Now, volatile doesn't necessarily mean what you think it does. So volatile liquid means it has a low boiling point. And so it has a low boiling point. And all the esters have that. The next thing it has is a fruity smell. So esters that have fruity smells are often used in things like candles. They're used in perfumes. And anytime you get a fruity smell from a perfume or a fruity smell from a candle or even a fruity smell from, something in cooking or baking or something has been added, that's always an ester molecule that's giving that smell. Another use then of an ester, so in this particular example, ethyl ethanoate is the ester. That's used as a solvent in glues. So certain times in chemistry you may need to dissolve something. Water won't dissolve it, alcohol won't dissolve it. Sometimes an ester will dissolve it, and ethyl ethanoate is a good solvent. Let's have a look at the physical properties. So again, we're looking at boiling point and solubility. So let's start with boiling point. So they have a low boiling point, and here's why. So what I've done is I've drawn out an ester molecule on the left and another ester molecule on the right. It's just flipped and turned around. They're both ester molecules. There is no hydrogen bonding here, mainly because, well, there's no hydrogens. So because there is no hydrogen bonding, that means the bonds that are between the ester molecules are not very strong. Therefore, if they're not very strong, you don't need much energy. And if you don't need much energy, that gives rise to a low boiling point. So no hydrogen bonds there. However, where hydrogen bonds do come in is when we're talking about solubility. So what we've got an example of here is a water molecule. So this water molecule, again, as we've seen before, oxygen is negative and hydrogen is positive. In the carbonyl group, the oxygen again is negative and the oxygen is positive in the carbon. So you end up getting an attraction between the oxygen and the hydrogen. So in this case, there is hydrogen bonding here. There is hydrogen bonding. Because of that, you have two polar compounds. So this is a polar water compound, polar H2O, and this is also a polar compound, and it's polar because of the carbonyl group. It wouldn't be as polar as carboxylic acid, but it is still polar, and like dissolves like, therefore polar will dissolve polar. In terms of organic solvents, esters are also soluble in organic solvents such as methylbenzene, and that's the main organic solvent that we compare it to. We'll be talking more about organic solvents in a few chapters' time. That pretty much finishes esters. There's a couple of things about esters in terms of how they're formed, but we'll be looking at those sort of reactions at a later stage. So the final section that we're going to look at is aromatic compounds. Now, aromatic compounds are compounds that contain benzene ring. So compounds that contain benzene ring. Now normally what we do is we draw out a benzene ring structure like this, and there's alternating double and single bonds, so double single, double single, double single. But that can also be drawn as a hexagon with a circle in it, and there's a reason for that. That's due to a thing called delocalized pi bonds. Now, I'm not going to get into that just yet. This is something we need to look at models in school and stuff like that. So we'll have a look at it again when we hit 6th year. But generally, benzene rings, it should be drawn like this. Although it doesn't matter if you draw it on the left either. It makes no difference. So benzene compounds. So first of all, benzene. Benzene is carcinogenic. So carcinogenic. And of course, I'm sure you know what that means. That means that causes cancer. That's when benzene is on its own. However, if you react benzene with other substances, it ceases to be carcinogenic. So for example, you can take a molecule like this, which is basically benzene, and if you put a methyl group into it, CH3, this then becomes methylbenzene. Now, methylbenzene is not carcinogenic, and methylbenzene is actually used, as we've seen already today, is used as a solvent in the chemical industry. So just by changing the structure very slightly, turns something that's highly carcinogenic into something that's relatively harmless. Other examples of compounds that contain benzene but aren't actually carcinogenic, well, the first one up here, this substance, I'm sure you know, is aspirin. So as you can see, there's your benzene ring just there. And where are all the carbons in this? So the carbons are at the nodes. So for example, I'll mark it in here in red. So there is a carbon there, there is a carbon there, and a carbon there, and all the way anywhere where there's sudden change in direction of the bonds, there's carbons. So that's aspirin. The next one down is paracetamol. So again, you can see our benzene ring just drawn slightly different in there. That's the structure of paracetamol. And then also another place that it's used. So benzene or aromatic compounds are used in the pharmaceutical industry. Another place they're used is down here, which is food additives. And as you can see, vanilla. So anytime you get a vanilla taste, say in a milkshake or an ice cream, or a vanilla smell that's in a candle, these all contain benzene rings. You can see oranges can also, this actually isn't a benzene ring. If you look at that very carefully, there's only one line in it. Grapes contain benzene rings. Wintergreen, absolutely no idea what that is, but that contains a benzene ring as well. Cinnamon contains a benzene ring. And what you notice, stuff with benzene rings are all very fragrant, the strong smells from them. So there you go. We got food additives, we got pharmaceutical. It also is used in things like insecticides, herbicides, so things like Roundup, stuff that you're going to put on your weeds when the sun is out, and also dyes and detergents, stuff that you wash your clothes with. So aromatic compounds used on a regular basis. There's a little bit more in this chapter to do with natural products, and there's a couple of experiments that have to be done. Obviously we can't do them here, but this certainly gives you a good start. The esters, there's an awful lot in it. Take your time, go back over it, spend a few days looking at it, and try to understand it as best you can. Okay, that's great. Thanks very much.